In this video, we're going to take a quick look at the tangent function, and we're just going to practice evaluating some exact values for tangent. So how I would start is let's just quickly recall the exact values for sine and cosine. They're kind of two more common trigonometric functions. We have this list of important angles given in both radians and degrees, and we have this nice little trick to remember the exact values. We start for the sine column by writing 0, 1, 2, 3, 4. We square root everything. We divide everything by 2. And technically, these are the correct answers, but there's some cleaning up we could do. For example, square root of 0 over 2, that's just going to be 0. Square root of 1 over 2, that's just 1/2. So we can rewrite that. Square root of 2 over 2 we can't simplify, same with square root of 3 over 2, but square root of 4 over 2 is just 2 over 2, which is 1. So there we go. 0, 1/2, square root of 2 over 2, square root of 3 over 2, 1. For cosine, we just write that same thing backwards. 1, square root of 3 over 2, square root of 2 over 2, 1/2, 0. And now you can calculate tangent by doing sine of theta over cosine of theta. And that's not too bad, especially if you've already done sine and cosine over here. But there's also like a nice way to memorize it. So how I remember it is you do kind of have to remember there's a 0 here, a 1 here, and an undefined down there. And then you need to make sure that you have two 1 over square root of 3's. One of those is the number 1 over square root of 3. The other is you have a 1 on top of a square root of 3. And if you put those all together, there you go. Those are the exact values for tangent in quadrant 1. So using this, let's go ahead and see if we can evaluate some of these. So what I'm going to do for each of these is I'm not only going to find what the value is, but I'm also going to draw a picture that kind of illustrates what this is. So let's start with tangent of pi over 6. First, I want to find pi over 6 on the unit circle. It's like around here. It's in quadrant 1. Since it's in quadrant 1, I know the answer is just going to be from this chart exactly. And it's going to be 1 over square root of 3. So not too bad. One thing that is important to note is that tangent represents a slope. So it makes sense that we have a positive answer here because this is a positive slope. And it's not a very steep slope either. What about tangent of 5 pi over 3? Ooh, I'm going to add one more in here. We're going to do tangent of 3 pi over 2 when we get to the end there. Okay, 5 pi over 3. So where's 5 pi over 3 on the unit circle? Well, we might remember that looks more like pi over 4. Let's do... You might remember that we have pi over 3 here. We have 2 pi over 3 here. We skip over 3 pi over 3. We have 4 pi over 3 here. We have 5 pi over 3 here. There's a better way, well, this is a pretty nice way to remember it. There's a more official way to kind of find where that's going to be, and we'll talk about that later. So, anyhow, we have tangent of 5 pi over 3. What's that going to be? Well, I know that tangent of pi over 3 is square root of 3. So I know tangent pi over 3 equals square root of 3. And this is going to be that same value just in quadrant 4. So I could think about this in a couple ways. I could remember my all students take calculus thing, which tells me that in quadrant 4, cosine's positive, but the others are negative. So I know my answer should be negative, but I could also think of this as a slope. This is a downward facing line. It's a downward slope, so my answer should be negative. So my answer is going to be that square root of 3, but we make it negative instead. Okay. What about tangent of 3 pi over 4? Let's go ahead and kind of go through the same process. We have pi over 4, we skip over 2 pi over 4, we have 3 pi over 4, and I could keep drawing the other ones, but hey, we got where we needed to. Again, I'm going to look, what's tangent of pi over 4? What's the corresponding one in quadrant 1? I know that tangent of pi over 4 equals 1, but this over here has a negative slope. So tangent is going to be negative, it's going to be negative 1. What about tangent of 180 degrees? Now I'm giving it in degrees, so, well, 180 degrees is over here. And you might be able to answer this just by thinking of it as slope. What's the slope of this horizontal line? It's 0. Woo, so crazy. Okay, let's do tangent of 2 pi over 3. I'm going to scroll down a little bit. You can still see most of the table. Okay, so we'll go ahead and draw our lines again. We have pi over 3. We have 2 pi over 3 over here. We have, you know what, I'm going to change this problem. Because we've been doing a lot of things in quadrants 2 and 4, we need something in quadrant 3. So how about something like 4 pi over 3? Oops. Something like 4 pi over 3, which happens to be right here. Okay, so we're going to take a look here. I know that tangent of pi over 3 from my exact value chart here is square root of 3. And if I look at tangent of 4 pi over 3, that's kind of the same line. It should have the same slope. So we're actually going to have a positive square root of 3 as my answer here instead of negative. Let's do one more before we do the trick question. Tangent of negative pi over 4. Now, so far we haven't done much with negatives. But basically what negative says is to just kind of like reflect it down or kind of go backwards around the circle. So if this here is tangent of pi over 4, tangent of negative pi over 4 should be this here. We know that tangent of pi over 4 equals 1. So tangent of negative pi over 4, this is a line with a negative slope. That should be negative 1. Okay, last but not least, our trick question. Tangent of 3 pi over 2. Where's tangent of 3 pi over 2 on the circle? Well, here's 0. Here's pi over 2. Here's pi, and then 3 pi over 2 is down here. So what we notice is it's kind of like pi over 2. It should behave the same as pi over 2. But there's something unfortunate about pi over 2, is that tangent of pi over 2 is undefined. And that's going to be the same for 3 pi over 2. We see that we have a vertical line here. And vertical lines have an undefined slope. So we're just going to write undefined. Okay. So there we go. There's some examples with tangent, just calculating some values of tangent around the unit circle.